This is challenge activity 8.1.1, and this is about hypothesis testing for two population means. And we have a left tail t-test here. The question is, a company would like to know if efficiency can be improved through a training course for employees. So a sample of employees is taken, and the time taken for an employee to complete a task before training and after training is observed. So right away we can tell that this is a paired t-test because the same subjects are involved in before and after sample. All right, so we have the summary for the hypothesis test shown here, and we have to answer these questions. So let's start with what is the sample size n? So we can see that the sample size is shown here for the observations are 30. So sample size is 30. Degrees of freedom are 29 because df equals n minus 1 for a t-test when we're using the t-distribution. So it's 30 minus 1, 29. Point estimate for before training. Point estimate here is going to be the sample mean. So we have a before mean and an after mean. So the before mean is shown here, 33.1, and after mean is 31.7. Right, and then we can see that this is a left tail test, so we need to get the test statistic and the p-value. Test statistic here is shown here. T-stat is negative 2.282, so that makes sense. It's between -2 and -3 here. And the p-value, so we are shown probability of t less than equal to t, one tail and two tail here. So we need to use the one tail p-value. So the one tail p-value is 0.051. Okay, so that answers all of the questions, and so let's check the answers, and those are the correct answers. The next question is in an online math tutor service would like to claim that the average time spent taking a standardized test after students go through tutoring is less than average time spent before. So in other words, that tutoring helps to finish the exam quicker. A simple random sample of students takes a pre-test and then goes through tutoring and takes a post-test. So again, it's a paired t-test because the same students are taking the pre-test and the post-test. So what are the population parameters in this case? So out of these options here, the difference in the sample sizes, that's incorrect. It's difference in the two sample means, that's not correct. We're looking for the population parameters. The mean time spent for all test takers before and after tutoring. This is the correct answer. All right, is the two sample hypothesis test a paired t-test or unpaired? It is paired because the same students are taking the pre-test and the post-test. What is the level of significance? So now we have to look at this table, the summary table here. So here we can see confidence level is 95%. So the level of significance is 100% minus whatever the confidence level is, 95%. So it would be 5%, and we would enter that as 0.05. So what is the null hypothesis? The null hypothesis is that the average time spent on the exam after tutoring equals the time spent before. So then under the null hypothesis, tutoring does not really help. What is the alternative hypothesis? So the alternative hypothesis would be that the average after is less than average before. That is the claim that the online math tutor service is making. Should the null hypothesis be rejected, or does the null hypothesis fail to be rejected? And for this, we need to look at the p-value. So first of all, this is a one-tail test. It's a one-tail test because alternative hypothesis involves one tail. And the tail is on the left side of the distribution because we have a less than sign. So for one tail, we need to read the p-value for one tail, which is 0.084. compare that to the level of significance, which is 0.05 here. And so right away you can tell that we will not reject the null hypothesis because the p-value is greater than the level of significance. So we fail to reject the null hypothesis. And the conclusion is that there is insufficient evidence to support the claim that the mean time spent taking an exam after tutoring is less than the mean time spent taking the test before tutoring. And so those are the correct answers. This is challenge activity 8.1.2. This is about hypothesis testing for two population means. And this time we have a right tail t-test. So the question is, a real estate agent believes that the mean home price in northern part of a country is higher than mean price in the southern part. And the agent would like to test the claim. So a simple random sample of housing prices is taken from each region, and here are the results. So this time we have an unpaired t-test because we don't have the same house prices being tested before and after some scenario. We have two regions and we have a simple random sample from each region. So we have an unpaired t-test situation here. So what is the sample size? So this time the sample size is going to be the sample size for the southern region plus the sample size for the northern region. So total will be 36. The degrees of freedom for an unpaired t-test will be n1 plus n2 minus 2. So n1 is 18, n2 is 18, so that's a total of 36 sample size, and then minus 2. So that would be 34. Point estimate for the southern part of the county, we have x bar for s. So x bar, small x bar, remember, represents the sample mean. So the sample mean for the southern part of the county is 155.056, and the point estimate for the northern part is 168.889, right? And now the t-test using the table here. So we need to first find the test statistic. So we have a one-tail test here. So we will we'll read the test statistic, which is 1.949, and then the p-value will be for the one tail. That would be 0.03. Okay, so that's all of the questions. Let's check, and we have the correct answers here. The next question is, a maker of dietary supplements would like to claim that a new supplement increases performance on an IQ test. So IQ tests are administered to a simple random sample of people taking the supplement as a treatment and as a control group. And the results are shown in this table here. So what are the population parameters? So clearly the difference in sample size is not correct. Difference in the two sample means is not correct because we're talking about the population parameters. Now these two options here are not entirely correct. So this is an error here, but the correct answer would be that it's the mean score in each of the two groups here. So this is the population mean within each of the group. So it would not be combined. So this is the correct answer here. Is the two sample hypothesis test a paired t-test or unpaired? So again, this time we have an unpaired t-test because the control group is independent from the treatment group. So we don't have the same subjects tested before and after. So this is going to be an unpaired t-test. The level of significance here is 100% minus the confidence level, 95%. So that would be 5% or 0.05. What is the null hypothesis? Well, the null hypothesis is that the mean for the control group equals mean for the treatment group. So that's always the case. The null hypothesis involves the equal sign. and the alternative hypothesis. So the claim here is that the supplement increases performance on an IQ test. So what that means is that the treatment group, the mean will be greater than the control group. Or in other words, the mean for the control group will be less than mean for the treatment group. So this would be the alternative hypothesis. Now, should the null hypothesis be rejected? So for this, first we need to see that this is a one-tailed test and the tail is on the left side. Okay. The test statistic is 0.632 and the p-value for one-tailed test is 0.267, which is much greater than 0.05. So we will fail to reject the null hypothesis. And the conclusion is that we have insufficient evidence to support the claim that the mean score of the supplement group is higher than the control group. And those are the correct answers. This is challenge activity 8.1.3. This is about hypothesis testing for two population means, one-tailed t-test. The question is, a sales manager for a large department store believes the customer spending per visit with a sale is lower than customer spending without a sale and would like to test that claim. A simple random sample of customer spending is taken from without a sale and with a sale, and the table has these results. So the first question is, what is the sample from without sale? So n without. So that's given here for observations. For without is 200 and with is 150. The point estimate for the spending without sale is 82.904. The point estimate here would be the sample mean. So this is the sample mean here. And then the point estimate for spending with sale is 71.316. All right. Now we need the we're running the t-test, so we need the test statistic and the p-value. So the table here has the test statistic here, negative 2.465, and the p-value is 0.0071. So we've answered all of the questions there. One thing to note here is p-value is much less than the alpha, which would be 1%. So it's 100% minus 99%. The confidence level would be the level of significance. So that's 1%. And so the test is significant, right? So let's just check the answers, and those are correct. And the next question here is, a middle school teacher believes that a reading rewards program results in less time to read a book after the program is completed. So the program is increasing the speed of reading the book. So the teacher chooses a simple random sample of students and records the time taken to read a book before the program and after the program. And so the results are shown here. So the population parameter. So what is the population parameters here? So it wouldn't be the first two options. This option here says the mean time taken to read a book for all students before and after the reading program. And this is correct. What is the level of significance? So that would be 100% minus the confidence level. So 5% or 0.05. Is this a paired or unpaired t-test? This is a paired t-test. And the reason is that the same students are tested before and after the program. So it's a paired t-test. The null hypothesis here would be that the mean after equals mean before under the null hypothesis. And the alternative is that the mean after is less than mean before. Okay, so that would imply that students are taking less time to read the book after the program. Should the null hypothesis be rejected? So it's a one-tailed test because the alternative hypothesis is less than, and the tail is on the left side of the distribution. So the p-value we read is one tail, and it's 0.0063. Compare that to 5% here. is much less than 5%. So we reject the null hypothesis. And the conclusion is that there is sufficient evidence to support the claim that the mean time taken to read a book after the program is lower than before the program. And those are the correct answers. This is challenge activity 8.1.4, and this is about hypothesis testing for two population means. And this time we have two-tailed t-tests. So the question is, a company that develops an automated customer service model is interested in knowing whether two versions, A and B, will get different ratings from the customers. So participants in a focus group are taken through the samples from both versions, then they take a survey to rate each version. And so the summary of the data obtained from the study is given below. Assume ratings from the different surveys generally have the same standard deviation. So here's the summary table. First, we need to find n. And so n here is going to be 15. This is a paired t-test situation here. So the same subjects are basically taken through samples, the samples for both version A and B. And so the survey that they take is on A and B, and it's the same subjects taking the survey. All right, so the sample size is 15, so therefore the degrees of freedom will be 14. So 15 minus 1, 14. The point estimate for version A is, the point estimate in this case is the mean again, is the sample mean. So it is, for version A is 33.133. And for version B is 28.67. The t-test here, this time we have a two-tailed t-test, so we have two tails. And the t statistic is given here is negative 1.426. So that would be the negative side, the left side. And the right side, we have a t distribution, so it's symmetric on the value 0. So the positive test statistic here will just be the mirror image of the negative 1.426. So it would be 1.426 plus 1.426. Okay. And then the p-value here, this time we're going to take the two-tail p-value. So that's 0.176. All right, so we've answered all the questions. Let's check the answers, and those are the correct answers. The next question here is, IQ test creators would like to know if scores between two tests are significantly different. To explore, a simple random sample of test taker is given test A and then B. So it's the same test takers that take test A and then they take test B. And the summary of the data obtained from the study is given below. So they carry out a hypothesis test. First question is, what are the population parameters? So it's not the difference in the sample sizes. It's not the difference in the two sample means. The sample mean score for all test takers from both tests combined, that's not correct because we have a paired t-test here. Same test takers are taking test A and B. And so the mean score for all test takers in each of the two tests. Okay. Is the two sample hypothesis test a paired t-test? That is correct. It's a paired t-test. What is the level of significance? So that's 100% minus 95%, the confidence level. 5% is the answer, or 0.05. The null hypothesis always is that the first mean equals the second mean. The alternative hypothesis is the claim that is being made. And in this scenario, because we are testing whether they are significantly different, whether the two tests are significantly different, so the alternative hypothesis is going to be not equal. That's what it means to say that they are significantly different. Should the null hypothesis be rejected? So we look at the p-value for the two-tailed, which is 0.026, and that is less than the level of significance, 5%. So yes, we reject the null hypothesis. And the conclusion is that we have sufficient evidence to support the claim that the mean scores from the two tests are different. And so those are the correct answers. This is challenge activity 8.2.1, and this is about hypothesis testing for two population proportions, and it's a left-tailed z-test. The question is, a state housing department is trying to determine if housing prices in county B are lower than in county A. So the department decides to randomly sample recently sold houses in both counties and determine what proportion sold for more than $250,000. So the proportion is defined as the number of houses sold over $250,000 divided by the total number that was sold. And of course, this would be sample based. Since County A is considered larger than County B, the housing department chose a large sample for County A. So we can see that County A has 900 observations, County B has 500 observations. The results are shown here, and we have to answer these questions. So the sample size for County A is 900, for County B is 500, so that's shown here. The sample proportion for County A. So here, when it says success, what that means is there were 665 houses that sold over $250,000 out of the total 900. So the proportion here, the sample proportion for County A would be 665 divided by 900. So let's use Excel to calculate that. So it's 665 divided by 900. So that is 0.739 when we round it to 3 decimal places. So 0.739. Sample proportion for County B, again, we'll use the same formula here, 340 divided by 500. So 340 divided by 500, 0.68. Right, so well, we have two more questions here. We need the test statistic, which in this case is the z-score. So the z-score is shown here is negative 2.346. All right, and the p-value is 0.009, and we can just enter all of it. So 0.00939. All right, so we've answered all the questions. So those are the correct answers. Go to the next one. The manager of a coffee shop is trying to determine if drive-through customers buy fewer items than customers who come into the shop. So the manager randomly samples both populations and calculates the proportion of customers in each that buy 3 or more items. So that's the proportion, the definition of the proportion. It's the number of customers that buy 3 or more items divided by total number of customers in the sample. The results of the data collected are shown below. So what is the population parameter here? So the population parameter would be the proportion of all customers in each category that buy 3 or more items. Okay, so that would be the correct answer here. What is the level of significance? So we can see here the confidence level is 90%. So the level of significance is 100% minus 90%, that's 10%, or 0.10. The null hypothesis is that the proportion of drive-through equals proportion in shop. And the alternative is proportion drive-through is less than proportion in shop, right? Because the manager's claim the manager was trying to determine if the drive-through customers buy fewer items than customers who come into the shop. So should the null hypothesis be rejected? So we can see the p-value is 0.444, which is much greater than 0.1. So we fail to reject the null hypothesis. And the conclusion is that we have insufficient evidence to support the claim that drive-through customers buy fewer items than in-shop customers? And that is the correct answer. This is challenge activity 8.2.2, and this is about hypothesis testing for two population proportions, and it's a right-tailed z-test. So the question is, a city council is trying to determine if library B with extended hours has a higher proportion of patrons under the age of 18 than library A, which closes at 6 p.m. So the proportion is higher for library B than A. That is the claim. A random sample of patrons from both libraries are checked, and here are the results. So looking at this, we have 41 out of 100 is the proportion for library A. Well, first of all, the number of observation or sample size for A is 100. For B is 150 here. So for library A, the proportion is going to be 41 divided by 100. So that's 0.410. And for B is 68 over 150. So let's calculate that. And that's 0.453. Okay. The Z score is shown here is 0.6717, and the p-value is shown here is 0.2514. So we have answered all the questions, and the answers are correct. The next question is, a pharmaceutical company is trying to determine if a new drug is more effective than the current standard drug. The company tracks random samples of patients on each drug and calculates the proportion that see an improvement in symptoms. So if the company is trying to determine if the new drug is more effective, then there would a higher proportion of patients or subjects would see an improvement. So the proportion for the new drug would be higher than the standard drug. So what is the population parameter? So here, the proportion of all patients on each drug that see an improvement in symptoms. That is the population parameters. What is the level of significance? The confidence level is specified as 99%, which is 0.99, so it would be 1 minus 0.99 or 0.01. The null hypothesis is that the proportion of the new drug equals proportion of the standard or the old drug, and the alternative is that the proportion of new is greater than proportion of old. Remember that the proportion here signifies the proportion of patients or subjects that see an improvement in symptoms. Should the null hypothesis be rejected? Well, the p-value is 0.1094, much higher than 0.01. So we fail to reject the null hypothesis. And there is insufficient evidence to support the claim that more patients on the new drug see an improvement in symptoms than patients on the current drug. And so those are the correct answers. This is challenge activity 8.2.3, and this is about hypothesis testing for two population proportions, and this is a one-tailed z-test. The question is, a university department chair believes that the afternoon section of a large survey class has a consistently higher proportion of students that pass the class compared to the morning section. And the chair checks a random sample, and so we have to carry out the hypothesis test. This is the summary data provided to us, so let's answer these questions. So first, for the morning section, we need the sample size, and we can see for the morning section, the sample size was 500 here. And then for the afternoon section, the sample size was 600. And now we have to calculate the proportion for the morning and the afternoon section. So remember that the proportion is going to be successes over observations. So for the morning section, it would be 419 over 500. So let's use Excel to calculate that. And then for the afternoon, it's 532 over 600. Right, so it's 0.838 for the morning section and 0.887 rounded to 3 decimal places here for the afternoon section. Right, so we have answered these questions, and now we need to specify the z-score. So the z-score is provided here. It's 2.366, and the p-value is 0.0089, which is provided right here. Right, and so that completes this question, and we have the correct responses here. The next question is, an advertising firm is trying to determine if a lower proportion of interactions from online advertising results in sales compared to proportion of interactions from television advertising. And so the firm is carrying out this hypothesis test. So the critical idea here is, if a lower proportion of interactions from online advertising results in sales compared to television, right? So the first question is, what is the population parameter here? So it's clearly not the first two responses. The correct response is the proportion of all interactions in each category that results in sales. Okay, so this is going to be the correct answer here. What is the level of significance? So you can see in the table here, we have the confidence level as 95%. So level of significance is 5% or 0.05. The null hypothesis is that the proportion online equals proportion of the television, and the alternative is that online is less than television. Now, should the null hypothesis be rejected? Well, the p-value here is 0.00169. That's much less than the level of significance, so we will reject the null hypothesis. And there is sufficient evidence to support the claim that proportion of sales generated by online is lower than proportion generated by television. And so those are the correct answers. This is challenge activity 8.2.4, and this is about hypothesis testing for two population proportions. Two-tailed z-test is the scenario now. The question is, an online retailer has a new website and would like to compare the proportion of customers who made a purchase from the old website versus the proportion using the new website. So the retailer takes a simple random sample of customers and carries out this hypothesis test. So let's answer these questions. So for the old site and the new site, we need to know the sample size. So for the old site, the sample size is 400. And for the new site, the sample size is 100. Now we need to calculate the proportions. So for the proportions, we would look at the this row here that's labeled successes, and it's successes over observations. So 156 customers out of 400 in the sample made a purchase using the old site, and 49 out of 100 using the new site. Okay, so let's calculate the proportion here for the old site. 156 over 400. And so that is 0.39. Now using the new site is 49 over 100, which is just 0.49, right? Now we need to know the z-score. Now this time we have a two-tailed distribution, right? So we have a z-score that will be here and one that will be here. The one that's here is provided here. You can see that the z-score is 1.819. We know that would be entered here because it's positive. And then we notice that the z distribution is symmetric on around the value 0. Okay, so it's going to be just the mirror image of this value, which would be negative 1.819. And the p-value that's provided here is 0.069. And those are the correct answers. The next question is two substance abuse clinics would like to compare retention rates for the programs offered by each to see whether the proportion of clients who stayed in after 90 days is different for the two clinics. So a simple random sample of clients from each clinic is taken. Okay. Now, what are the population parameters? Okay, so out of these choices, the first two are not correct because they relate to the sample. Population parameters are not sample based. The proportion of all clients for each clinic that remained in the program after 90 days, or the proportion of clients for each sample. And again, this is not the right answer because we're again discussing the sample here. So the third option is the correct answer. Now, what is the level of significance? So the level of significance is provided here. We can see that the confidence level is 95%. So the level of significance is 5% or 0.05. The null hypothesis is that the proportion of clinic A equals proportion of clinic B. The null hypothesis always involves the equal sign. And the alternative, for the alternative, we need to make sure that the option we pick is correct here. And for that, we need to read this line. Two substance abuse clinics would like to compare retention rates for the program offered by each to see whether the proportion of clients who stayed after 90 days is different for the two clinics. So this is the key, is different for the two clinics. When we're talking about there being a difference, it's going to be not equal to each other. So proportion of clinic A does not equal proportion of clinic B. So that is the alternative hypothesis. Now, should the null hypothesis be rejected? Well, we have the p-value as 0.029. That's less than the level of significance. So we will reject the null hypothesis. And there is sufficient evidence to support the claim that retention rates for the two clinics are different, right? And so those are the correct answers.